Hello, everyone. Thank you for joining us today for our ALS Webinar Wednesday series. My name is Alex Yao. I'm a marketing coordinator for ALS North America, and I'll be facilitating the webinar today. Just a few helpful notes before we begin. If you're having technical issues with our webinar platform or any other questions, you can type your message or question using the chat function at the bottom of the screen. You can also select the hand icon to notify me of your status so I can assist you. All questions regarding the webinar material will be answered at the end of the presentation. Our presenter today is Wendy Hyatt. Wendy's the lab director in Tucson, Arizona. She's worked for the Tucson Lab for over 15 years. She began her career after graduating from the University of Arizona in 2006 with her BS in chemistry. ALS in Tucson provides analytical testing for several sectors, including but not limited to energy, mining, microelemental analysis, and research. Today, Wendy will be discussing an introduction to fuel testing. Thanks for taking the time to deliver this presentation. I'll turn it over to you now.
Thank you, Alex. Hello, everybody. Thank you and welcome to our webinar series on the introduction to fuels testing. Fuels testing is something that Tucson has been performing for over a decade. And over time, we've added other testing as well, but this webinar specifically just going to focus on fuels testing. So a little bit of background on the Tucson Lab. Right now, the facility that we're in, we moved here in 2019, but the lab was started in the early 1980s as Desert Analytics. It was founded by Dr. Richard Johnson. And originally, we performed microelemental testing for university and government research laboratories around the country. It was a relatively small lab. And in 2005, we were acquired by Columbia Analytical Services, and then finally acquired by ALS in 2011. And over the years, we've added capabilities such as the alternative fuels. We've added mining testing, including acid-base accounting, agronomic and physical analyses, as well as environmental testing, including carbon speciation and sediment, and column and batch extraction procedures. We are also ISO 17025 accredited. So first, I'm going to go over the different types of fuels that we test. There are traditional fuels such as coal, coke, and fuel oil. And then there are alternative fuels such as biofuels, biomass, wood chips, there's tires, refuse-derived fuel, municipal solid waste, bunch of different types of waste oils. There are liquors from the pulp and paper process. There's sludge, filter cake, and there's several other matrices that we're able to handle. While fossil fuels account for over 60% of our energy sources in the US, there is a steady increase in the use of alternative fuels that now make up about 1.5% of our energy source. The importance of alternative fuels, they're critical. It's a critical component in the quest to reduce dependence on historical sources of energy. Waste now is looked at as a viable energy resource. And most of the clients that we work with are adopting this process because they're able to take their waste and either use it as a fuel, or they're also able to sell it as a fuel to power plants and anybody else that might have a boiler that they would need to burn fuel in. So what are considered alternative fuels? It's any carbon-based material that can be used directly as a fuel or be used to create a fuel. We get alternative fuels from the forestry and agricultural waste. There's a list there: hog fuel, wood chips. There's a lot that comes from the pulp and paper industry. Municipal and industrial solid and liquid waste, that includes municipal solid waste, used tires, plastics, paper, sewage sludge, waste oils, and the black liquor, which is also from the pulp and paper industry. Also dedicated energy crops such as algae, switchgrass, and palm oil. There's pyrolysis oil from biomass and municipal solid waste, and also algae to jet fuel. And here's kind of a brief summary of the industries that that we serve. If an industry uses a boiler to burn fuel, they will be required to test that fuel. Also, if a company wants to sell their waste to a power generator, they too will need to have the fuel tested to determine the value of that waste and if it's environmentally acceptable to burn. One of the largest sectors that we work with is the pulp and paper industry. Some of the waste from the craft process, which is the process used to make wood into wood pulp, is used as a fuel by way of utilization of a recovery boiler in a nearly closed system. And we also work with power generators that have to abide by the boiler MACT rule, which is an EPA regulation. MACT stands for Maximum Achievable Control Technology. It's a regulation to establish emission limits on boilers that are major sources of hazardous air pollutants. New boilers have more stringent limits than older boilers, so every year those limits become smaller and smaller. There's also municipal solid waste to pyrolysis oil. This is the conversion of waste to clean energy through bioreactors and thermal composition to produce high calorific value gas and biofuel. A large amount of the work that we perform in Tucson supports the waste to energy industry. So here are a few charts. Municipal solid waste, do not call it trash, it's waste. The chart on the left shows the makeup of the municipal solid waste. And so you can see what basically is what goes into a landfill. And then on the right, you can see actually how much of that waste is kept in the landfill, if it's recycled, if it's composited, or if it's burned. So we're actually burning about 12% of the waste that we generate. So there's 292 million tons of waste produced in the US each year. As of 2018, 12% of it, of the municipal solid waste is burned in waste to energy plants, but that's not the only use of the waste. They also burn the waste so it can reduce what is actually kept or sent to a landfill, and that number is about 87%, which is a significant amount of waste that is kept from the landfill. So as you can imagine, it's a bit of a sampling challenge to have all of this waste from a landfill and be able to determine, to have an accurate account of what's in that waste and if it's good as a fuel. Quality data requires obtaining a representative sample for testing. We see that across the board with any type of sample that you're working with. For municipal solid waste, it's a special challenge. Normally, we receive municipal solid waste in 5-gallon buckets. And whoever the sampler is, they're actually, in a pile of waste and taking a 5-gallon bucket and just sampling it from there. So we see all different types of matrices within that bucket. Some clients will perform some of the processing prior to submittal, but it's not necessary. Our Tucson Lab actually specializes in preparing these types of samples as well as many other matrices for analysis. As you can imagine, you can't just take a piece of waste and put it into an instrument. It has to be broken down much further in order to be useful in an analysis. So our sample preparation process, why do we want to prepare samples? We want to homogenize the sample. Analysis of a representative sample is critical for accurate recovery of analyte and reproducibility. And then for particle size reduction, and some methods actually require a certain particle size. And also, as I mentioned a little bit earlier, most instrumentation can't accept the large pieces of sample. So it's important to ensure that each aliquot used for analysis is representative of the entire sample. And not only does Tucson routinely grind samples for fuels testing, but we also grind samples for other testing that we perform in-house or that we might send out to another ALS lab. So it's something to think about if you encounter a sample that is non-routine, it's a little different, and you can't think of a way that you can break down the particles small enough for analysis, contact us, and we will find a way, the best way to prepare that sample. So we're talking, first talking about municipal solid waste. So here are some pictures. At the top left, that's pictures of literally the waste that has been taken from a bucket. And what we typically do is we will air dry that sample at about 40 degrees Celsius. And the air dry process is basically to dry most of the sample to where we're not handling really wet sample. And for municipal solid waste, because there's plastic in there, we cryogenically grind the sample. So the samples are frozen with liquid nitrogen to make them more brittle. And this helps prevent gumming up the grinding equipment, and it makes it a lot easier for the grinding process. So once we have that sample, it is first ground down to about 10 millimeters. And then it's taken through another mill to grind it further down. Some testing can be performed on the less than 10 millimeters. For most of the fuels testing that we perform here in Tucson, it has to be less than 1 millimeter. But you can see even in the sample, after it's ground up, you could see the little pieces, the different colors, but it's much more homogeneous than the original sample. And typically for these types of samples, we might have to, do duplicate or triplicate analysis in order to get a full representation for a particular analysis. Here are some other examples of fuels that are how they start out and after they're ground up. For the tire-derived fuel, that's another sample that needs the cryogenic grinding. And with tire-derived fuels, we also remove the wire that's in the tire. The weight of the wire is then used in a calculation that enables us to report some of the data as wire-free, or we can report it with the wire. The wire actually adds an insignificant amount to the heating content specifically, and it's generally not accounted for in any of the other testing. But we can actually test it either way. Or reported on both different bases. And then over to the right, you can see the wood waste. The wood is relatively easy to grind up, and same goes for the paperboard. And you can see with the paperboard, we can get it to a much finer particle size than say the plastics or the tires. So I'm going to go through some of the common fuels testing that we perform here in-house. That includes the Proximate and Ultimate Analysis. We perform total halogens for bromine, chlorine, and fluorine. We do metals analysis on, I believe we perform metals testing on over 50 different metals. We also perform mineral analysis of ash, and the samples actually ashed at 750 degrees Celsius in an oxygen atmosphere in a furnace. And then we analyze the ash from that process for metals, and we report that on an oxide basis. And we will also perform carbon and sulfur on that ash as well. And we perform the higher and lower heating value. For BTUs, we analyze the higher heating value, and then we utilize the moisture content and the hydrogen content in order to report a lower heating value. We also, as within the ALS network, can perform a suite of environmental analyses. So Tucson would prepare the sample, perform the testing that we do here, and then we would send it to a sister lab for some of this other environmental testing. So you would really have a one-stop shop. You would just have to send it to one place, and you would get, we would handle everything for you on the subcontracting side. So this instrument here is our LECO AC600 bomb calorimeter. The bomb calorimeter is used to determine the heat content of a sample. A sample is combusted in an oxygen atmosphere, and thus heats up the reaction vessel. The vessel is submerged in water, and the temperature difference of the water before and after combustion is measured. The heating value is then calculated based on this temperature difference. We perform the proximate analysis. The proximate analysis includes moisture, volatile matter, fixed carbon, and ash. We also perform loss on ignition. The loss on ignition is performed typically at 950 degrees Celsius, and moisture is performed at 105 degrees Celsius. Volatile matter is a test. The sample is put, it's about 1 gram of sample is put into a ceramic crucible. And for the volatile matter test, a lid is put on top of that. And the instrument is heated up to 950 degrees Celsius. And it's performed in a nitrogen atmosphere. And this is used to determine the weight of volatiles that are evaporated, which leaves behind the fixed carbon and ash. And then the last step of the proximate analysis is the ash step, and that's performed at 750 degrees Celsius in an oxygen atmosphere. So with this thermogravimetric analyzer that we have, it's an automated method, and it measures the sample weights throughout the analysis. And once the weights are consistent from one weighing to the other, the analysis is considered complete. Here we have, this is a picture of our LICO SC832. We've performed carbon and sulfur analysis on that instrument. For carbon, hydrogen, nitrogen, and sulfur, these are performed using combustion analyzers such as the SC832 that combust the sample in a pure oxygen atmosphere at a high temperature. And then the resultant gases are detected by IR or through thermal conductivity. Other testing that we perform may include combustible carbon, which is a total organic carbon, where the samples are treated with acid and heated to remove the inorganic carbon. Then that sample, that same sample aliquot, is analyzed for total carbon to give us the combustible carbon or total organic carbon. We can also determine the total carbon and sulfur in combustion residues in ash, which I briefly described before. As part of the boiler MACT regulations, this testing includes mercury testing, chlorine, fluorine, and bromine, as well as total select metals. This instrument here, this is our mercury analyzer. We perform, it's a high temperature combustion followed by gold amalgamation, and finally detection by AA. What's nice about this instrument is there is no digestion step prior. So you just take your ground sample, or if it's a liquid oil, you just put that right into the instrument and you get a total mercury. It's a nice method because there is no prep method such as a digestion step. You get better recovery of control standards. It's more accurate than some of the older methods that are used for mercury. Also part of the boiler MACT regulations is halogens, total chlorine, bromine, and fluorine. These are determined by EPA 5050/9056. The sample is combusted in a par bomb, similar to bombs that are used for the heat content. And there is a basic solution, it's called a scrubber, that is added to the bomb prior to combustion. The sample is combusted in an oxygen atmosphere, and the resultant gases are trapped in that scrubber solution, and then the liquid is analyzed by ion chromatograph. The IC yields better recovery of each analyte compared to other titration techniques that have been used in the past that may not differentiate the chlorine from fluorine or bromine. Lastly, part of the boiler MACT rule is total select metals. We perform a variety of different methods for that. That includes EPA 3050 or 3051 that uses hydrochloric acid and nitric acids. We also have the capability here in Tucson that not many other labs have, and that's the ability to perform hydrofluoric acid digestions in the microwave. And the hydrofluoric acid is required for total dissolution of refractory compounds such as silicates and titanium oxide. So this enables us to get to be able to report a total dissolution, and specifically for method ASTM D6349, which is the method for the mineral ash analysis that is typically used for fuel testing. So on to sample submission. Basically, you would obtain pricing or a quote to see what our availability is and our capabilities from your ALS sales representative or project manager, or you can contact me directly, and you'll see my contact information at the end. Work really does need to be quoted on a project by project basis due to the complexity of the samples and the grinding process. Some samples, they have different grinding techniques for different matrices, so it's really important that we have as much information up front as possible. And most of the samples can be submitted ambient unless they contain biological activity, such as some sludges. Our typical turnaround is about 10 to 12 business days for the fuels work, and rushed options are available. And that concludes my presentation on our fuels testing in Tucson. So we'll go ahead and open this up for questions. Alex, were there any questions that anybody put in the Q&A in the chat?
I'm going to give just a couple minutes for people to submit their questions.
Okay.
They can write out, if anybody has any questions, please write out your question using the Q&A function in your toolbar at the bottom of the webinar. Attendees can also see all submitted questions using this window. So I'll just give a couple minutes for people to type in their questions, and during that time, I'll just review some brief notes. This webinar presentation has been recorded. All participants of this webinar will receive a follow-up email once the recording is available to view. We will also post our webinars on our ALS Global website and our ALS YouTube channel in the webinar playlist. I encourage you to find a wide range of video resources and past webinar Wednesday presentations available there. Also, please follow our company page on LinkedIn as we post announcements and registration links to future webinars and other valuable resources and updates. And still waiting to see if anybody has any questions. Haven't seen any submitted yet. Otherwise, I guess it looks like you've answered everybody's questions.
Yeah, and please feel free to contact me, give me a call, shoot me an email. If any other questions come up, I'm more than happy to answer them. Just trying to get the word out on Tucson and our fuels capabilities.
Great. It looks like we do have a question from Rafaela. They ask, do you always have to prepare the sample as in granulate it, or do you receive ready-made samples?
We do receive already dried and ground samples, and if that's the case, then we won't process them again. It typically will still need to perform a total moisture analysis in order to report on a moisture-free basis. But if the sample is prepared prior to sending it to Tucson, that is fine.
Great. And if there are no more questions, maybe we can go ahead and end. Like I said, Wendy's contact info will be in the follow-up email, along with the recording of this webinar presentation. I just want to thank everybody for attending and hope you guys enjoy the rest of your week.
Thank you, everybody.
Thanks. Oh, it looks like we do have one more question.
Okay.
Follow-up question is, could you explain better the purpose of each analysis, or is there a final report for the samples?
For the proximate and ultimate analysis, that's usually used to help a client determine the viability of their fuel. So it really depends on what the client is using that data for. So we would provide the final report, and then they would, a lot of times that information, such as the heating value, it's used in heat rate analysis for their system. So oftentimes the data that we provide for the fuel viability is used for further calculations that help them determine more about their efficiency of their process. So we do send a final report, but oftentimes our values are used in further calculations. And then in regards to the boiler MACT rule, oftentimes our reports are what are actually submitted to the EPA from the client. So they have to prove that they're within those emission limits. And so those final reports are sent directly to the regulators. Does that answer your question?
Yes, he says.
Okay.
All right, well, thank you, everybody. And like I said, have a great week.
Thank you.